Hello everybody. So this is day 8 of Advent of Code challenge, and today's challenge is something Easter bunny installation. So the whole city is covered with some antennas, and they send out all kind of different frequencies in order for the Easter bunny to get better sales from the customers. So the puzzle input looks like a data grid, and it has locations where the antennas are located. And the antennas are with different names. So different names have a different frequencies with them. And so what is our job is to find some kind of anti-nodes, so that, for example, if we have like two antennas, their names are A and A. So these two antennas create antinodes that are from one place they are one distance, and from the second place they are the double the distance from the second place. So yeah, so these 2 points they create two signals like that. But if you have three antennas, then three antennas, they create more signals. For example, this and this antenna, they create signals like that. And also the second and the third signal antenna, they create this kind of frequency place. And the other one is outside of the grid. So yes, so if we have many antennas, then our job is to find where those antinodes are located. And so our job is to find that and how many of those antinodes there are. And also we have to take into the consideration that one place can only be antinode place for one time. If it's in different frequencies, then it's well, it will still count as a one. Yes, so this is our puzzle, this is our challenge, and so let's try to do it. So I have my Advent of Code Visual Studio over here ready, and yeah, let's try to solve it. Now, first thing is that when we look at this board, we can see that this is our board, and this is our real input. So real input has a lot of different frequency bands. So they are expressed with the different letters. And so yes, so there are different frequencies, and we need to find in which places they have this anti frequencies. First thing while solving it is that I am thinking that we should get the same type of letters or same type of antennas to some kind of our own list. Yeah, so probably I would say that we could make some dictionary. Let's say some antennas. It could be some kind of dictionary, so that it will be that, for example, name will be this O and 0, and then locations. It will be list of the coordinates, x and y coordinates. So this is how I think we could get our data inside. I don't know if we need grid for this, so that do we need to save all of the elements inside grid? I think we do not. So, but I think what we do need is that the length of the x and y coordinates. So maybe I will also get those things as well. So I will declare some variables, x length and y length. First let them be post zeros, and also let this antenna variable will to be 0 as well. I will just erase everything that's inside. All right, let's try to get it for x in open input.txt. First thing, maybe I think it can be so to make it as a list. So let's make it as a list. Separate one line to the list of list elements. So it can be x.strip like that, and then maybe the x length, this x length, I think we might need it in the end. So maybe if it's if y length equals 0, then x length is length of k, something like that. And so that the y length is something that we will just start to increase. And now it is now we should get all of those elements inside to our antenna variable. So how could we do? Maybe we should check each element, and if this element is a dot, then we will do nothing. But if it's some kind of other sign, then we will store it to our antenna dictionary. Yes, so let's do it. So for I a in enumerate, and let's enumerate that k variable. Then let's say if a not equal to the dot, so a can be, if it's a dot, then we will ignore it. But if it's not a dot, then we can do something about it. Then now we need two things. We need its coordinates. We need both x and y coordinate. X coordinate is how is the x coordinate? X coordinate is the element I that we have over here, so the index, and the y coordinate is the y length, this variable that we have over here. So it will be, let's say, ticked object will be some kind of curly braces. Let's call that the first element is name, and let it be this a. Let it be this a, so that the name of the coordinate, and the other one will be the coordinates. So let's maybe start with a y coordinate first, so that the y coordinate is going from up to down. So this will be y length, and the other one will be the index e, so that the horizontal coordinate, and so this is just like the horizontal coordinate like that. Yes, and now we need to put some variable name as well, chords, like that. All right. Now if we have done it, let's see how it works. For x in antennas, print x. So let's just see if we got all the coordinates and antenna names to our variables. Yes, so my debugging is going a little bit slow when it's so what happened? Yes, so now we also have antennas that append ticked object. Yes, like this. So very good. So we got everything nicely to our object. If we put some, I don't know, some k to our input data as well, so I'm pretty sure this k is also it's our object list. Yes, so it is. So now what we can do is that what we want to do, well, there's not that much we can do with if the object is in this kind of format. what we would like to do is that somehow separate all of the different antenna names from each other. So, for example, with the we want the list of O coordinates by yourself, list of A coordinates by yourself. So we need to separate them somehow. So like we don't care what's the name of the antenna name. We just need all of the coordinates, and then we can do something about those later. All right, we can do so. First thing, maybe if you put some A over here as well. Is also that we want to sort them as well. So if I just added one new coordinate, then they are like not sorted. So what I would like to do is to get the antenna sorted. So it will be let's sort them. Sorted antennas key equals lambda. For the in the name antennas key lambda. So let's see how it goes. I need to copy my code from somewhere. The T name. Lambda. Something like that. Let's see if it is T name. Yes, something like that. Yes. And now we could also group it somehow. Grouped, it is a default tick, so we need to import collections from collections. Let's import default tick. So this is a default tick, and let's call it list. And for entry in antennas, grouped. Okay, I will just copy this code. This is this way how it is copied. So yeah, so what I did over here, so it works like this. So what I wanted to do with this is that if they are in different antenna location, different antenna types, then we will just get them to one of the group classes. And now we have a group of different elements arranged by themselves. So, for example, for group in groups, print group. All right. I think it looks better now. Yes. So that's what we wanted to achieve, and that is what we achieved. So that all of the antennas that are with a O name, they are together in one array, and the others that are with A, they are together in one list. So that's what we wanted. All right. So we got that one, but so the question was how we could find these anti-nodes. So those places that are like away from each other, where this anti-frequency occurs. So for that thing, we should create maybe let's call it anti-nodes. Anti-nodes. So this is just like one list that holds all the anti-nodes values. And what we can do is that if we have it on separate groups, then we can just like declare new methods, like for example get anti-nodes for one group of the antennas, and we just only the input parameter is the group, and that's about it. When we finish the anti-nodes method, then this anti-nodes method is something that just adds anti-nodes to this anti-nodes list of data. Yes, this get anti-nodes is just something that adds something inside to that anti-nodes. All right, let's get it. Def get anti-nodes and group over here. So what are we going to do? Our input is this kind of array. There is many elements over here, and we need to just like check one element with another. So first thing we have to do is we have to make a 2 times loop. So it is how it is for y in range. Let it be from 0 to length of the group -1. So this is the first loop, and the second one is for j in range. So the second one is going from I to the length of our group. So this is just like we watch all the group data. All right. And so inside this method, what should we do is let's just get the x and y coordinates, y and x from group y, group first, y and x elements from the first point, and the second one is xy, it is from the group j. All right. Now, what should we do with this x and y coordinates? So I made this kind of list of these points over here. So if we have 2 points, let's call the point number 1 and point number A and B. So if the first point is in a position 1 and 2, and the second one is in 2 and 4, then the anti-nodes point names will be like over here, so, and over here. So it is that this point will be in what y coordinate is 0, and x coordinate is also 0, but the other point is the y coordinate is 3 and x coordinate is 6. So it is so that the both coordinates, they are like this the first coordinate is, it is just like what it is just 2 minus 1, and then this it is 2 minus 1 is 1, and we subtract this 1 from this coordinate from the closest point. So 1 minus 1 is 0. So it goes like that. And from the other side, it goes kind of the same way, that the y coordinate 2 minus 1 is 1, and then this is 1, and then we just add it 2 plus 1 is 3. So that means that we add the absolute difference from 1 and 2. This is like the y distance. Then we add it to the value that is the bigger one. This is, and the value that is smaller one, from that we subtract it. So this is how we get those coordinates. All right, and in order to get them, maybe let's make some parameter y distance. So this is absolute value of what it is, y distance. So it is y2 minus y1. It doesn't matter which one comes first. X distance is absolute value of x2 minus x1. All right. And if we have those things, then somehow we need to get the sign, y sign and x sign. I don't know. We somehow need to get sign. We also need to think about if it's anti-clockwise or clockwise diagonal, or like downwards diagonal or upwards diagonal. So somehow we need to get sign. And over here, let's put out all the coordinates that we have. So somehow we need to get signs, but after we get those signs, we can do it so that if 0 and over here, let's do that I1 plus y sign times y distance is in between 0 and length, y length, and the same thing for x value if it's between 0 and x1 plus x sign times x distance is, and it's less than x length. Then we can add something to that anti-node. Let's say new node. So the new node is the same thing that's over here. New node, and over here as well. And let's do anti-nodes dot append. New node, new node. And the same thing goes for the second direction anti-node. But for that we can just say that ys and xs is minus ys and minus xs. So yeah, what it was that if to one place we need to subtract from the one element, and to the other one we need to add it. So if it's adding or subtracting, so for one it's definitely one. If for one it's minus, for the other one is plus. So we can be assured that we just change the signs, and for the other one it will work. So let's just take the same method that we had before, and just everywhere just change y1 to y2. I think this will work. Let's just change everything. So it's x2. Yes, like that. And now we need to just figure out the sign, and the sign method. How can it be? Get sign y1, x1, y2, x2. So how can it be? So why should it be 1 or minus 1? It will be, and what do we want over here? So first we want to get it for y1. So it will be positive if y1 is bigger than y2, and else minus 1. So yes, like that. If, and the same thing is for x. If x1 is bigger than x2, else minus 1. And then let's say return y and x. All right, that's pretty much it. Then let's see. Let's just print for x in 19 nodes, print x. Let's see what we're gonna get. Yes. Or do we have some error? Let's see what's going on. So quite a lot of code. So we got something. That's quite a lot of them. So let's see. So that the length of 90 nodes. What did we just do? So I will also check what was the answer. For this data, there was 14 unique locations. 14 unique locations. So how many did I get? Wait, print length of 90 nodes. 14. I think that we got a little bit more than 14. So how much did we got? We got 29. We got a little bit more than that. So yeah. Anyway, well, this is how it goes. Yeah, I got it up by myself, and the link is in the description. Anyway, for the second part, it was quite the same one, quite the same way, but it is just that antinodes can come like infinitely more. It's just like not the one point that's come from this line, but there are many lines, and now you need to count them more. Yes. So I will end it over here. I solved it by myself as well, and yeah, I had a little bit problem with getting this y and x values, but yeah, in the end I found that this is quite a good method, that just like get one sign, and from this to the second one, the signs are just like upside down, and yeah, yeah. So yeah. Yeah, and for the second part, it's just like it's not a if cycle over here, but you can just like do that the while, and just yes, it is some kind of m equals, let's call it from while you do some loop over here, and then just you just also add this times m over here times m over here, and over here you also had times m, and here you do m plus equal 1. So it will just create multiple lines like that. But all right, I think I will end it over here. So see you guys.